For over a century, one single idea has been the foundation of quantum physics. It says that everything in the universe, from a beam of light to you and me, can be two different things at once. It's a concept that seems totally impossible and throws all of our intuition out the window. But behind this baffling idea is a simple, even elegant logic that completely rebuilds our picture of reality. And it all begins with one famous experiment. Let's start with what feels like common sense. In our everyday world, things are either particles or they're waves. Particles are things like a baseball, a speck of dust, a bullet. You know exactly where they are. You can point and say, it's right there. They're solid, you can count them, and if you fire one at a wall with two holes, it's going to go through one hole or the other. Simple enough. Waves are totally different. Think about ripples in a pond. A wave isn't in just one spot. It's a spread out disturbance, a pattern of energy. And when a wave hits a wall with two openings, it doesn't pick one. It flows through both and creates new waves on the other side. Those new waves then interfere with each other, making a complex pattern of peaks and valleys. For centuries, this separation was obvious. Particles are particles, waves are waves. The two are mutually exclusive. At least that's what we all thought. And this is where the story gets wonderfully weird with what's often called the most beautiful experiment in science, the double slit experiment. Imagine you have a device that fires tiny particles like electrons, one by one, at a barrier with two slits in it. Behind that barrier is a screen that lights up wherever an electron lands. Since an electron is a particle, you'd expect it to pass through either the left slit or the right one, leaving two distinct bands on the screen, right? Just two simple piles of electrons. But that's not what happens. Instead of two bands, what slowly builds up on the screen, one electron at a time, is an interference pattern. It's a whole series of bright and dark stripes. The exact pattern you'd get if you sent a wave through the slits. This result should feel impossible. It suggests that each electron, all by itself, somehow went through both slits at the same time, like a wave, and interfered with its own path. It's as if the universe is messing with us. How can a single thing be in two places at once? Scientists then thought, if we can just figure out which slit each electron goes through, we'll solve this. So they put a detector next to the slits, a gatekeeper designed to do nothing but watch and record which path each electron took. So what do you think happened? The second they started watching, the interference pattern completely vanished. With the detector in place, the electrons went back to behaving like particles, creating just two simple bands on the screen. The very act of observing, of measuring which path the electrons took, forced it to choose a slit and destroyed its wave-like behavior. It's as if the electrons knew they were being watched. The mystery just got deeper. The answer to this riddle is both incredibly simple and profoundly strange. Wave-particle duality. This is the core idea of quantum physics. It says that things like electrons and photons aren't just particles or just waves. They're a bizarre mix of both. Back in 1924, a physicist named Louis de Broglie proposed that all matter has a wave-like nature. Every single particle, from an electron to a planet, has a wavelength that's related to its momentum. Now, for big objects like a baseball, that wavelength is so ridiculously small that we'd never ever notice it. But for a tiny electron, its wavelength is big enough to make a difference. But here's the simple idea. An unobserved electron isn't a tiny little ball. It's better to think of it as a wave of probability, a spread out field of potential that describes all the places it could be. This probability wave travels, passes through both slits, and interferes with itself. When that wave hits the screen on the other side, the probability collapses into a single point, and we see a dot on the screen, a particle. The act of measuring at the slit does the same thing. It collapses the wave, forcing the electron into a definite position. And once it's forced into one spot, it can't create that wave interference pattern anymore. This is a concept that has totally reshaped technology and even our understanding of what it means to exist. If you enjoy having your sense of reality completely rewritten, think about subscribing. We've got a lot more of the universe to explore. So, is an electron a particle or a wave? The quantum answer is yes. It's not one or the other. It's a quantum object that shows us one face or the other, depending on how we choose to look at it. The universe, it turns out, isn't built on a foundation of solid certain things. It's built on an undecided reality of probabilities. And the simple, elegant, and impossible idea is that at its core, everything is always two things at once. It's a fundamental law of nature. Until next time, remember, stay curious and keep exploring. Thanks so much for watching.